that we understand. So yesterday we just graphed these equations like y equals or f of x equals. What we really like to do, we like to find the vertex because that gives us the max or the min. The other thing that we like to do is we like to solve it, which means all you do is you set it equal to 0. So you just change y, or f of x, and you just say equals 0 now instead of equals y. When we do that, we get the solutions. The solutions are where it crosses the x-axis. So we have lots of words here that mean that. So first of all, we have roots, all right? So sometimes you'll see, find the roots of this equation. The roots are just the solutions. And really the roots are the solution to any equation. It doesn't have to just be a quadratic equation. When we solve a linear equation, the solution is the root also. We also call these zeros. And the zeros are where it equals 0, which means it's where it crosses the x-axis, also known as the x-intercepts of the graph. So there are four words that pretty much mean the same thing, that you need to know these 4 words, all right? So roots means the same as zeros, means the same as solutions, which means the same as x-intercepts. On the ECA, which means hopefully probably the same kind of question on the ICEP 10, they use those words interchangeably. And sometimes they just give you a graph and they say find the roots or find the zeros. And it's already graphed for you. So you just have to know what that word means. And if you know what that word means, you just look at the graph and you give me the x-intercepts. But if you don't know what that word means, you might give me the vertex and you might get the wrong answer. So probably on your next test, I'm going to give you a question and I'm going to give you one of these 4 words and I'm going to ask you to list the other 3. List the other 3 words that mean the same as roots. Or list the other 3 words that mean the same as solutions, because really important that you understand all of those are the same thing. Which is why I made you write it out. So when we are solving a quadratic, when it says solve, it means give me the roots or the intercepts, the x-intercepts, or the solutions, or the zeros, which means if it's graphed already for you, which I'm giving you some on your homework that are graphed already for you, you just have to tell me where are the x-intercepts. What would you say? -2, right? And there's also one here at -4. That's it. I've seen that question on the graduation test before, but you have to know what you're looking for on that. Now, obviously, all your homework's not going to be like that, because I'm going to make you graph some yourself and then tell me where it crosses. But this is the basic idea. Solve it means where does it cross the x-axis. All right? Now, this one had 2. Do all quadratics cross the x-axis in 2 places? No, and that's what the next slide has here, is there are 3 options that happen when you solve a quadratic. When you have a parabola, sometimes it's like what we just did. Sometimes it crosses in 2 spots, and you have 2 real solutions. And maybe you remember from last year, sometimes the vertex is actually on the x-axis, and if the vertex is on the x-axis, it's only going to touch in one spot. So it only has one number. We call that like a double root. And then sometimes your parabola either starts above the x-axis and opens up, or maybe it's down here and it opens down, and that actually has no real solutions. That's what's going to lead us to talk about imaginary numbers later in this week or next week, probably next week. I'll just leave that there for now. Okay, so just know when you graph these, sometimes you're going to say there's no solution, sometimes you're going to have 2 answers, sometimes you're going to have 1 answer. So, if it's not already graphed for you, you have to do what we did yesterday. You have to make a decent graph so you can see where it crosses, and then you have to state where it crosses, whereas yesterday your answer was just the graph. What's the first thing you notice about this equation that looks different than yesterday? It doesn't have f of x. It's not in that standard form, right? So definitely they're not going to have f of x today because they should be equal to 0. If it's not equal to 0, the very first thing you have to do is make it equal to 0. So I'm going to say here, set equal to 0, which means I'm just going to add this 4 back over with the other stuff. So now I'm going to have x squared minus 4x plus 4 equals 0. And now I have ax squared plus bx plus c. And just like we graphed these yesterday, you can either just make an xy chart and pick a bunch of points, or what I think is the best choice is start with that negative b over 2a, find that vertex, and then either use your y-intercept or use another point. And so I'm always going to start with negative b over 2a. So Jasmine, what's b in this problem? Negative 4 over 2 times, Caitlin, what's a? It would be 1, because there's nothing in front of there, so we know that there is a 1. So then we're just going to reduce that. Negative 4 divided by 2 is negative 2. I always write it as an ordered pair, but if...
Would that be positive for those?
Oh my gosh, thank you. Look, I did the whole thing wrong. Because it's negative b, right? Look, I'm so sorry. So excited. All right, here, look, I got to show my work better. So remember that the formula is negative b. B is negative 4. So if I'm plugging in a negative of a negative 4, the negatives should really cancel out. Yes? Yes. Thank you. Thank you. I was so excited for the next step. I messed up my negatives. Yes. So if you realize that that's just going to be a positive, you don't have to write those double negatives. So what I was trying to say, I was so excited to get to this part, I always write that as an ordered pair. So like I always just do this when I get my answer because I want to go back and find that y value. But if you'd rather just make an xy chart, right? If you'd rather do this and you want to put 2 right there and find the y that goes with it, if that helps you more, you just need to make sure you find that corresponding y when you do this problem. So this is where you have to go back, and this is where maybe it's a little bit confusing because we have that equals 0. 0 and y are kind of interchangeable depending on what we're talking about here. When we're trying to find the y that goes with it, we're kind of just going to forget that that says 0 over there, and we're just going to plug it in right here, and whatever we get is going to be the y that goes with it. And so that's where I said yesterday you can use a calculator and still use a calculator, but I'm just going to do the work here and say 2 squared is 4 minus 4 times 2 is 8 plus 4, which means I get 0. Is that true? So I always start with that vertex. So I'm going to go over here to the point 2, 0. And remember that that's going to cut my graph in half. And if your y-intercept is easy to find, that's what I think your next answer or your next point should be. Remember that yesterday we said that C is always your y-intercept because that's what we get when x is 0. So that means that it's a free point. I can go up here on the y-axis and make a 4 and flip it over, and I have a really quick, accurate graph here. So vertex, find the y that goes with it, use the y-intercept if you can. The difference between yesterday and today, yesterday the directions just said graph it. Today it says solve by graphing. So you have to tell me the solution. And the solution is x equals whatever the x-intercept or intercepts are on here, which in this case is, it's 2. If you recognize that the vertex is that solution, did you even have to finish that whole graph there? You didn't, because the vertex is the solution. So you need to make sure you actually give me that solution today. How do you feel?
So we don't each graph all that much.
If the vertex is the solution, I'm okay with that. If it's not one solution, then you're gonna have to graph more.
Again,
You have to write x equals 2. So the very first example that was already graphed for us crossed at really nice points. This one crosses at really nice points. Not all parabolas are going to cross at nice points. And if we aren't using a calculator to help us, we're going to have to approximate those. So let's look at one more. Maybe. And the directions even say this in your homework. It says, if exact roots cannot be found, meaning that it doesn't cross an exact point. They don't want you to just round it and be like, oh, that's 2.5, because we don't know that. They want you to just approximate it, which just means what two integers or what two whole numbers is it between. And I'll show you what we can do as we graph this. So step 1, I'm going to do just like we did on the last one. Something to notice right away is x squared is negative. So when we graph this, it better be opening down or we've done something wrong. It's already equal to 0, so I'm good to go. I'm just going to do negative b over 2a. See if I can do my math right this time. So that b is positive, so that's going to be negative 4 over 2 times a is now negative 1. Just plugging in the a, plugging in the b. So negative 4 over negative 2 is positive 2. So just like last time, I'm going to find that y value that goes with it. Just like we talked about yesterday, be really careful when you're doing this. If it's not a fraction, it's not really that bad to do without a calculator, but just remember, when the negative is outside of x, you square it first and then you put the negative on it. So if I'm plugging 2 in here, 2 squared is 4, and then that negative is still out there. So make sure you kind of pay attention to that. And then 4 times 2 is 8 minus 1, which I think gives me 3. And again, you can use the calculator on that. Just make sure you don't put the negative inside the parentheses. And every time I go straight to my graph after I have that vertex. And again, it can even help you if you put that dotted line in there. What is the y-intercept on this one? It's just whatever c is. So that means right here is negative 1. And since it's 2 away from the axis of symmetry, I can go 2 this way. So you see how this one didn't work out so nice when it crossed the x-axis? Like it crosses somewhere in between there, but we don't really know where. And honestly, it's usually an irrational number that happens at. So it says state the 2 integers that the root is in between. So this one is between what 2 numbers? 0 and 1, right? So I could say x is, and I'm just going to say between 0 and 1. Because there's a whole lot of numbers between 0 and 1, right? There's actually an infinite amount of numbers between 0 and 1. Think about that. Can't you just keep getting smaller and smaller? Or bigger and bigger and closer to 1? Infinite. Whoa. That's. But you could always think of more numbers in between there. Think about that. And then what about this one? It's between what? 1, 2, 3, and 4? So I'm going to say between 3 and 4. And right here is a good example of why graphing by hand is not the best method. Because if you want an exact answer, this is not going to be the way you can get an exact answer. Which is why we're going to use calculators tomorrow, and it's why we're going to look at other ways that we can get exact answers to do that. But if it doesn't work out nice, you just need to say between there. And then the last thing I wanted to give you is just to kind of push a little bit to make you think about, what if they didn't even give you a graph? What if they just gave you an XY chart? Could you look at that and tell me when you know it's crossing the x-axis? Like between what 2 numbers it's crossing? So look at this one while I get your homework ready. I made this XY chart yesterday for a quadratic graph that doesn't cross at nice points. And so these were the x values on my chart, and these were the y values on my chart. I want to know, can you explain to me, how do you know where it crosses the x-axis? Between what 2 numbers does it cross the x-axis? Anybody got an idea?
Are you crossing off some of these?
Anybody got an idea about this? Let's look back on this one. What do you notice about all the values here leading up to this 0 compared to the values after it?
Ooh, those were all negative.
You notice these were all negative, and then after it crossed, what happened?
It got positive.
It got positive again until when?
It got negative.
It crossed again, and then it got negative. So when it crosses the x-axis, are the y values always going to change from positive to negative or negative to positive? Except in the case of this, that's the exception to that, right? Because when it doesn't. So looking at this, since this is a positive y value, and then it switches to a negative y value, do you agree that somewhere in between -2 and -1 it had to cross the x-axis?
Yeah, but then.
And then it stays negative until between 3 and 4, it goes again from a negative to a positive. So I just wanted to kind of put that thought in your head that you could figure out where the zeros have to be if you just had an XY chart. So like in between here would be a 0, and in between here would be a 0. So I'm not going to make you graph 5 of these because that's a bit insane, but I don't want you to scribble them all the way out because I want us to do this tomorrow on a calculator. So you can like just X out the little number sign, but don't X out the whole graph.
All of them?
Not all of them.
All of them.
So I want you to wait on doing number 6. So just like circle or X out number 6 only, not the graph. And number 8. Number 9 gives you a equation. You can just yeah. So that's 3 to graph. 1, 2, and 3 are already graphed for you, so you just have to state the zeros. And then number 9, try number 9. I'm sure we'll talk about it tomorrow, but I'm telling you, number 9 is what's going to be on the graduation test. Those of you taking the PSAT next week, there's going to be questions, story problems. Like we can't just skip the story
Our
problems.
PSAT is next week?
I'm pretty sure it's next Wednesday.
Couldn't remember twice for that.
PSAT, right? PSAT is the one. SAT, you have to schedule to take that on a Saturday somewhere else. No, neither one of those are the graduation test. The SAT is what you take for college, to get into colleges and for scholarships. The PSAT, I'll tell you, if you're planning on taking dual credit classes, if you can do well in the PSAT, it saves you from having to take another test to do dual credit. Some people say, I never knew that. When I'm like, well, you didn't do well enough on the PSAT, so you have to take another test. So if you think you're going to take dual credit, whether it's dual credit English or dual credit A-push or dual credit, I don't think A-push is dual credit anymore. Dual credit with me, pre-calculus is dual credit. If you do well,
English doesn't give us the credit.
you have to do AP credit, right? That's not dual credit. You have to pass the test. But anyway, if you do well enough on the PSAT, it exempts you from having to take the actual exam. All right? But we'll talk about that more later. Do your homework.
Yeah.
Oh, it's